This video is lesson 4.9, Graphing Quadratic Inequalities. And in this video we are going to graph quadratics the same way we have in the last videos, but this time we're also going to have shading because of the inequality symbol. So for the first example, we have y is less than negative x squared. So this is less than. And when we get to the point where we're ready to graph it, we know that less than means to shade below. Now notice it's just less than, there is no equal to. So that also tells me that this line, when we graph it, is going to be dotted. Okay, so this is not too difficult to graph. I'm just going to squeeze my graph in here. Y is less than negative x squared. Well, this is the regular parent function. It has not been shifted right or left because it doesn't have any parentheses. It hasn't been shifted up or down because it doesn't have anything at the end. So this graph starts at the origin, and its slope is going to be -1 because right here would be -1. So I'm just going to go down 1 over 1, and I'm going to mirror it on the other side. And the hardest part, I think, is that I'm going to connect it in a way that it's dotted. And that's not the most beautiful graph in the world, but it is the basic idea. Now when we shade this, we want to shade below. And so I'm going to shade underneath, down here, and try not to mess up my beautiful dotted line. So my shaded section turns out to be inside the U down here. And that's all there is to it. You graph it and you shade it. That was a really simple example because it didn't have a lot of shifting, so let's try another one. If we have an example like this that is in standard form, remember that to graph it, we're going to have to know x by finding negative b over 2a. Okay, so just kind of keep that in your mind that we're going to do that in just a minute. Now this symbol right here is less than or equal to. Less than or equal to. So less than is going to tell me to shade below, and the or equal to sign that's right there tells me to make this line solid. Okay, so let's find our vertex and axis of symmetry and see if we can graph this. So x equals negative b over 2a. My b is 5. My a is going to be 1 just like last time. And notice there's nothing at the end, so we know that c will be 0. So negative 5 divided by 2 times 1. So x is negative 5 over 2, which is negative 2.7. Let's try that again. Negative 2.5, not 2.7. Negative 2.5. Okay? Now to find the y value that goes with this x, I'm going to plug into my original equation. So it was 1x squared, so I'm going to put negative 2.5 squared plus 5 times negative 2.5. You can still see that point. And I'm going to do this in the calculator, and exactly as it looks. And when I do that, I'm going to get negative 6.25 for my y. Okay, now remember that these two things go together. Negative 2.5 comma negative 6.25, that is now my vertex. The axis of symmetry is x equals negative 2.5 because it's exactly the same as this x value we found just a moment ago. Okay? I know those two things, and the last thing I need is my y-intercept, and you might remember that the y-intercept is going to be right up here. The c is always your y-intercept, So our y-intercept is 0. So I'm going to take this all to the next screen and graph it. So y-intercept 0, let's see if we can remember it all. Negative 2.5, comma negative 6.25, that's my vertex. Okay, so let's go ahead and give myself a little axis. Okay. Be much better if I had graph paper. Okay, so negative 2.5 is about here. Negative 6.5 is down 1, 2, 3, 4, 5, 6.25. It's about down here. So if I go left, negative 2.5, and down 6.25, 1, 2, 3, 4. I'm going to have to add an extra line in there. I didn't do a very good job. How's that? Okay, now it's at negative 2.5, negative 6.25. And then my y-intercept was at 0. So 0. Remember, your axis of symmetry comes straight down the middle, cuts right through that vertex. That tells me how to mirror. So I'm going to take this point right here, and I'm going to mirror it. 1, 2, let's see, 1, 2.5, 1/2, 1, 2. So it's going to be right there for me to mirror it. Okay, now remember we said solid line. So we're going to graph this as a solid line. And it was less than, so that means to shade below. And below is out here. So this may seem strange, but this is shaded all on the outside of the parabola, nothing on the inside of the parabola. So it looks like that. Okay, the last example I have for you, the last thing we're going to do, is graphing a system of quadratic inequalities. And you probably recall a system means there's more than one equation. So in my example, I have 2 equations, and we're going to graph these 2 things. This first equation here, we're going to use, you can either use vertex form or the fact that it's a quadratic parent function. But the vertex for this is going to be at 0, negative 4. And I know that because there's not any parentheses here, so that means that it's shifted 0 units, and this part, minus 4, is at the end of my equation, so that's the down 4 part. And then when I do that with my vertex, then my slope is going to be 1, so I'm going to use a slope of 1. So I'm going to switch to the next page, and then we'll just come back to do the next one. So we're going to start at 0, negative 4. And our slope's going to be 1, so I'm going to go up 1, right 1, right there. And then I'm going to mirror it on the other side, right there. Now, I'm going to go back and look at this. I'm going to shade above because this is greater than, and it's going to be solid. So let's make this a solid graph. Solid graph. Shading above. Shading above means right here. Okay, so shading above on this one means inside. Now let's switch to the other equation. For this next equation, we're back in standard form. We have to use negative b divided by 2a. So our b is 7, so that makes negative 7 divided by 2 times negative 2, which is negative 7 divided by negative 4. 2 negatives divided will be a positive, and this is going to reduce to be 1.75. When I'll plug 1.75 back in for the x, remember I'm plugging it in where the x is, 1.75 squared there, and 1.75 here. When I plug that into the calculator as negative 2 times 1.75 parentheses squared plus 7 times 1.75 plus 4, I got that my y was 10.1. So that may seem like a strange graph, but it's not too bad. We'll get over there. 1.75 and 10.1. So I'm going to go over to the right 1 and almost to the 2 right there. and I'm going to go up 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my vertex is right about there. Okay, now I'm going to go back and I want to find my y-intercept. Remember where the y-intercept is? Very end. So my y-intercept is at 4. So 1, 2, 3, 4, that's my y-intercept right there. Remember the axis of symmetry would be over here. So when I do my mirror point, I'm going to go almost 2 units on this side. And really all I'm doing is just looking at it and trying to make it even. It does not have to be perfect when you don't have any graph paper. And even if you have graph paper, it doesn't have to be exactly perfect. Now I just need to go back and see, how do I shade this? Remember it was solid because this was equal to. This is less than, which means to shade below. So I'm going to shade below here. I'm going to try to make it a little bit, a little bit light. Because I want you to still be able to see where the other one would overlap. So I'm going to use green to come in here and outline this little area so you can see exactly where the overlap is, where the purple and the red are, is right in here. So just by making it a little bit darker, we have our solution. That's all there is to it. No practice problem tonight, and you can do your practice problems in class tomorrow.